All right, HL students, we're going to be talking today about properties of curves. So we're starting a new chapter here. We've learned so far how to do all of the different differentiation rules for all our different functions, and hopefully you'll remember them um, because now we're going to start applying them to curves and use derivatives to find many different things about curves, such as tangents and normals. So we'll talk about tangent lines and normal lines, what those are. We'll be looking at intervals of increase or decrease. Okay, when do you know that just by looking at a function without graphing it, uh, uh, what the intervals of increase would be? When is it going up? When is it going down? What are the turning points? When does it have a maximum? When does it have a minimum? And when does it does a function change its shape, the curvature? Okay, so these are all examples of applications of derivatives, and we'll be talking more about this throughout this chapter. So we're going to start today with tangents and normals, and I'll just get right into it, okay? Basically, a tangent line, well, we already know what a tangent line is, right? A tangent line and a normal line on a curve, okay, so if we have this curve, let's say it was y equals f of x, the tangent line will obviously be touching at a point of tangency, and the normal line is always the line that is perpendicular to the tangent line, okay, so it's always related to the tangent line. So if it's perpendicular, what does that mean? Well, the slope of this line is related to the slope of this line. If you remember back to Algebra 1, Algebra 2, pre-calculus, we talked about this, right? The slope of the normal line and the slope of the tangent line, or the slope of two perpendicular lines, will have slopes that are negative reciprocals of each other. Okay, so it's going to be one slope will be negative and flipped of the other. Okay, so for instance, if y equals mx plus b is the equation of the tangent line, then the normal line's equation will be y equals minus 1 over m, okay, where m is the original tangent slope, times x plus c, some other constant there, some other y-intercept. Okay, so this section we're going to be talking about lines a lot, and you will need to remember how to find equations of lines. All right, so let's look at example 1. It says find tangent to f of x equals x squared plus 1 at the point x equals 1. Okay. By the way, this is also from your textbook. Okay, so you could, if you would like to stop this video and just read the textbook, you are by all means welcome to do that. Okay, but I'm just going to walk you through this. If I have x squared plus 1, and I just go ahead and sketch that, and I need to find the tangent line, the equation of the tangent line at the point x equals 1, well, I need to find, first of all, the slope of the tangent line, right? Because in order to find an equation, I'm going to need a slope, equation of a line, I'm going to need a slope and a point of tangency. Okay, a point that the line passes through. So the point of tangency is the easiest one to find because I know that the line will touch the graph at one point. And how do I find that one point? Well, since I'm given the x coordinate, I just need to find the y coordinate, and that's going to correspond to my original function. Okay, so I just plug that 1 in, I get 2 out, and that's my point of tangency. Okay. Alright, so next step is, how am I going to find the slope of the tangent? Well, you should know from our previous work in chapter 18 that the slope of the tangent line is the same as the derivative of my original function at a certain point, at the given point, right? So at x equals 1, f prime of x is going to be the slope of the tangent line. In other words, f prime of 1 is the slope of the tangent at x equals 1. Okay, so since I now have a slope of 2, so m is 2, and a point, 1, 2, I now have a slope and a point, I can find the equation of a line. What form do I use? I can use point slope form. You don't have to use this form. You could use any other forms, right? You could use y equals mx plus b and just use that. You could just use um, um, just the slope formula, okay? But this is probably the easiest form. Just it requires a little bit less algebra, okay? So y and x stay the same. I just plug in y1 and x1 into my formula. Remember that this is now the coordinates, and I solve algebraically and I get y equals 2x. Okay, so y equals 2x would be the equation of this line, and we'll be doing some work with that later on. Okay, so that's example 1. You're welcome to listen to all the videos or skip some if you feel like they're too easy.